Eighth grade lesson 11.2 is angle theorems for triangles. You're going to learn about two triangle theorems, two triangle rules that you can use to your advantage. This lesson, though, your practice will be using it to your advantage, but it's explaining why they work so that it's something that your brain can digest much easier and recall. So the two theorems you're going to learn are the Triangle Sum Theorem, and actually you know this one already, so that one will be kind of a review. You just have now an official name to it. And then the Exterior Angle Theorem will be shown to you as well, and then you'll be able to apply both of those theorems in the lesson practice. So this begins the explanation of the Triangle Sum Theorem, and it's really just being familiar with all of the angles in a triangle. You may have tried this before. I feel like this is something we've seen in previous years, where you take a cutout of a triangle, you tear the corners off, the vertices off, and then you reapply them lined up with each other, and you find, oh, look at that, this angle plus this angle plus this angle equals a straight line. Because I know you already have learned that the inside angles of a triangle add up to 180 degrees, which is a straight line. So they tell you to go ahead and try this if you wish. What do you notice about how the angles fit together around a point? They make a straight line. We need another color. And what is the measure of a straight angle? That is 180 degrees. Hopefully that's in your memory banks now. So they ask us, well, describe the relationship among the measures of the angles of triangle ABC. So angle A plus angle B plus angle C adds up to be 180 degrees. That's a sum. The Triangle Sum Theorem states that for any triangle ABC, the measure of angle A plus measure of angle B plus measure of angle C equals 180 degrees. Can a triangle have two right angles? Think about that. I would have a right angle that's 90 degrees. If I had another right angle at 90 degrees, that's a total of 180 degrees. I need a third angle for it to be a triangle. There's no degrees left. So can I have a triangle that has two right angles? You're right. No, you can't. Because two 90-degree angles already equals 180 degrees. I would need another angle in there, and there's no room. Describe the relationship between the two acute angles in a right triangle and explain your reasoning. So remember, acute angles are the cute little ones that are less than 90 degrees. And so if I have a right triangle, we know one of those is 90 degrees. If we know every angle inside of that triangle adds up to 180 degrees, well, there's only 90 left, so this plus this must equal 90 degrees. So they both will add to 90 degrees to complete that triangle. 90 degrees plus this and this, these two together, their sum would be 90 degrees, so that 90, these two plus 90, is 180 degrees. This goes on to continue justifying that triangle sum theory where every angle inside of the triangle adds together to 180 degrees. And so they justify using what you previously learned on your transversal with the parallel lines. So we would imagine this being our parallel lines, and then we have this triangle inside, but we can imagine that if this line continued for the part of the triangle, that's a transversal going through, right? Or if I looked at it this way, this one is a transversal also going through that set of parallel lines. And so we can imagine that those extend and treat them like a transversal. So they say draw a triangle and label the angles angle 1, 2, 3. That's been done for us. Draw a line A through the base of the triangle. That's done. Parallel postulate says that through a point not on a line L, there is exactly one line parallel to line L. Draw the line B parallel to line A, done that, through the vertex opposite the base of the triangle. Extend each of the non-base sides of the triangle to form transversals S and transversal T. So there's S, there's T, like we had already drawn. And then label the angles formed by line B and the transversals. So we have angle 4 and angle 5. Now, because 4 and some angle are alternate interior mean they are inside of the parallels on alternate sides of the transversal. This is their transversal. So angle 4 and angle 2 are alternate interior angles. And we learned that alternate interior angles are congruent. So we know that this angle is congruent to this angle, has the same measure. They say label an angle 4 with a number angle into which it's congruent. It is congruent to angle 2. Then they want us to go to the next part over here. Because angle 5 and some angle are alternate interior angles, well, let's look at 5. Here's the transversal. We need an interior that's on the other side of the transversal here. And angle 5 and angle 3 are alternate interior angles, so they are congruent, angle 3. The 3 angles that lie along line B at the vertex of the triangle are angles 4, 1, and 5. They put it this way, angle 1, 4, and 5. Notice that they make a straight line. We know that angles that add up to a straight line, 1, 2, and 5, add up to 180 degrees because of the straight angle. Because angle 2 and 4 are congruent and angle 3 and 5 are congruent, you can substitute 2 for 4 and 3 for 5. Angle 1 plus 2 plus 3, measure of angle 1 plus measure of angle 2 plus measure of angle 3 is also 180 degrees. And this shows that the angle measures in a triangle is always 180 degrees. So that's just the proof of it happening. Once your brain has adapted to the proof that all the angles inside the triangle add up to 180 degrees. And I think this is already something you saw last year, so this is just that proving of it and giving the name Triangle Sum Theorem so that you can say, well, if somebody said, how did you get that answer? Well, the Triangle Sum Theorem says all the angles inside the triangle add up to 180 degrees. That's your justification. This next explore activity helps us make sense of the exterior angle theorem that you're going to learn about. And first we need to talk about some vocabulary that goes along with that. On a triangle, the interior angles are the angles that are inside. 1, 2, 3 are interior angles. That makes sense, right? An exterior angle is an angle that is outside of the triangle, like angle 4. He is not inside the triangle, he's outside. Exterior, outside. So angle 4 is an exterior angle. And then remote interior angles, these are the angles that are inside, interior, of the triangle, but they're not adjacent or right next to the exterior angle. So here's my exterior. I have angles 1, 2, and 3 interior. The ones that are not right next to angle 4, angle 3 is next door to angle 4. The ones that are not are 1 and 2. So not right next to is what they mean by remote interior angles. Remote meaning away from. So angles 1 and 2 are remote, away from, interior, inside the triangle, angles with angle 4. So there's a special relationship between the measure of an exterior angle and the measures of its remote interior angles. There's a connection between them, and this is what they're going to show us. First, they want us to extend the base of the triangle and label the exterior angle as angle 4. So we would extend that and call this angle 4. The Triangle Sum Theorem that we learned previously in the last page says that angle 1, the measure of angle 1 plus measure of angle 2 plus measure of angle 3 all add together to 180 degrees. We already covered that, right? We also know that the measure of angle 3 and measure of angle 4, measure 3 and measure of angle 4, together make a straight line. They form a straight line or a straight angle. And so when we know things make a straight line, we know that their sum, when you add them together, will be 180 degrees. So measure of angle 3 plus measure of angle 4 will equal 180 degrees. Okay, so we can use the equations in B and C to complete the following equation. Measure of angle 1 plus 2 plus 3, 1 plus 2 plus 3, is going to equal the measure of angle 3 plus the measure of angle 4, 3 plus 4, right? Because we had just said this equals 180 degrees and this equals 180 degrees, so we're just putting those together. If we use properties of equality to simplify the equation, basically looking at our equation and saying, let's eliminate the similarities on both sides. Well, the similarity on both sides is this one and this one. If we subtract angle 3 to both of them, then we are going to end up with this equation, the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 4. So the exterior angle theorem states that the measure of an exterior angle, similar to angle 4, this outside exterior angle, is going to be equal to, here's our exterior, right? It ended up equaling those remote interior angles, the ones that weren't next to him, when we simplified that. So it's equal to the sum of its remote interior angles. So they ask us, sketch a triangle and draw all of its exterior angles. Let's see. Okay, so here I have triangle with angle 1, 2, 3. I'm going to extend out all of the lines. I'll do a different color so we can see them clearly. That one extending, this one extending, and this one extending. Okay? And we will draw all of its exterior angles. How many exterior angles does the triangle have at each vertex? Well, at each vertex, you will notice, like let's say this vertex, he has an exterior angle here and here. This one has an exterior angle here and here. And this one has an exterior angle here and here. So each of them has 2. So how many total exterior angles does the triangle have? Well, it has 2 for each vertex, and there's 1, 2, 3 vertexes, so 2 times 3 is 6 exterior angles. So if I want to put that that exterior angle theorem to work, then I can, here's an example of how I might use it. So here's the exterior angle theorem. The exterior angle is equal to the 2 remote interiors added together. So here's my exterior angle, 52 degrees. It is equal to these 2 remote interior angles, the 2 interior angles that are not sharing this line with this. That's not sharing the opposite, it's not adjacent to that. So we know that this angle, 4y minus 4, added to 3y, the 2 remote interior angles, are going to equal 52. So I can go ahead and do my calculations, remove my parentheses because I'm adding together this positive, this negative, and this positive. So it's all addition, as long as I'm adding negatives. I can combine my like terms, 4 and 3y's, 4y's and 3y's together makes 7y's. Minus 4 comes down here. Add 4 to both sides of the equation, 7y equals 56. So now I'm just doing my multi-step equations and isolating my variable using inverse operations. Y is sitting here hanging out with a multiply by 7. The opposite of that is divide by 7 to both sides of my equation, and y will equal 8. So now that I know this unknown number is 8, I can plug 8 in here. 4 times 8, 32, minus 4 is 28. And I can plug 8 in here. 3 times 8 is 24. And I have now found those. So remember, for exterior angle theorem to use to your advantage, the exterior angle will always equal the remote interior angles, the 2 interior angles of the triangle that are not adjacent. to your exterior angle. If you add those two together that are away from it, it will equal that. And that's it. So use those to your advantage, those two theorems to your advantage to solve the practice problems they give you. The first few you might get hung up on a little bit, but you'll find yourself becoming an expert at these very quickly.